Hello friends, today we are going to be discussing sequence. It's a concept under the topic sequence and series. So we start by defining the concept sequence. What is sequence? A sequence of number is an ordered list of numbers arranged according to a certain rule. Rules such as if I have a sequence of 1, 2, 3, 4, dot 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 dot. This sequence is a sequence or is an infinite sequence of natural numbers. You can see natural numbers 1, 2, 3, for counting numbers 4 and so on. Because of this dot dot dot, it means it is infinite. It has no limit. Okay, we can also have a sequence example, a sequence of infinite sequence of odd numbers. This one is an infinite sequence of odd numbers. We can also have example 2, 4, 6, 8, dot dot dot, infinite sequence of even numbers. We can also have a sequence of 2, 3, 5, 7, 11, 13. This is a finite sequence of prime numbers because there is no dot dot dot. It ended in 13. Therefore, this sequence is finite and it contains prime numbers. Okay, we can also have a sequence of let's say 1, 4, 9, 16, 25, and so on and so forth. This is an infinite sequence of the square of natural numbers. If you square 1, you square 2, you square 3, you get 9, you square 4, you get 16. So there must be a particular order of this set of numbers before we refer to it as a sequence. We have different types of sequence. There is also a way to identify a polynomial sequence. In a polynomial sequence, the number that is going to always be added to a particular number to get the next number forms a linear sequence or arithmetic progression. What do I mean? You can see that what I added to 2 to get 5 is 3. What I added to 5 to get 10 is 5. What I added to 10 to get 17 is 7. What I added to 17 to get 26 is 9. You see that these numbers that I'm adding, 3, 5, 7, 9, is a linear sequence because a particular number is added to each one of them to get the other. In the same way as this, what I added to 2 to get 6 is 4. What I added to 6 to get 12 is 6. What I will add to 12 to get 20 is 8. What I'll add to 20 to get 30 is 10. What I'll add to 30 to get 42 is 12. You see that these numbers form a linear sequence of addition of 2. So this is what we refer to as a polynomial sequence, the arithmetic sequence. Arithmetic sequence. That's the number one type of sequence we're going to look at, arithmetic sequence. Arithmetic sequence, also known as arithmetic progression. Arithmetic sequence is also known as arithmetic progression. In this type of sequence, each term of the sequence is gotten by the addition of a particular number to the preceding number. That is, if I want to get a particular term, I'll add a constant, a particular number, to the number before it to get that number. And that particular number will continue to add to the preceding number to get the succeeding number is what we refer to as common difference. Say for instance, you have numbers such as 1, 3, 5, 4, 5, 7, 9, and so on and so forth. These are infinite. This is an infinite sequence of odd numbers. But we can see that when you add a particular number, which is 2 to 1, you get 3. You add the same 2 to 3, you get 5. Add the same 2 to 5, you get 7. Add the same 2 to 7, you get 9. So it is the addition of a constant to a number to get the succeeding number. That is what we refer to as arithmetic sequence or arithmetic progression. Another type of sequence we have is geometric sequence. Geometric sequence. geometric sequence. Geometric sequence is also known as geometric progression. It is also known as geometric progression. This sequence is gotten, each term in this sequence is gotten by the multiplication of the preceding number by a constant number. When you multiply a number by a constant number, you will get the next number. When the sequence has this order, you call it geometric sequence or geometric progression. Sequence such as, let's say, 2, 4, 8, 16, 32. You will see that in this sequence, when you multiply 2 by 2, you get 4. Multiply it again by 2, you get 8. Multiply 8 by 2, you get 16. Multiply 16 by 2, you get 32. So this is a finite sequence of a finite geometric sequence. Okay, a finite geometric sequence which is gotten by multiplication of a constant number to a preceding number to get the next number. So that is what we refer to as geometric sequence. We also have another that we call the harmonic sequence. Yes, we have another we call the harmonic sequence. Harmonic sequence, also known as harmonic progression, Okay, in this type of sequence is a fractional sequence. Okay, it is a sequence that is a fraction. We have 1 over 3, 1 over 6, 1 over 9, 1 over 12. This is a finite harmonic sequence, and this type of sequence, the denominator is an arithmetic sequence. The denominator of this harmonic sequence is an arithmetic sequence. So when you have a fraction where the numerator is a constant and the denominator is 1, that is a reciprocal, and the denominator is an arithmetic sequence or progression, you call it a harmonic sequence. Okay, this is what we refer to as harmonic sequence. We also have this special type of sequence we call Fibonacci sequence. Fibonacci sequence. Fibonacci. Okay? This is a special type of sequence when you have something like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on and so forth. If you look at this sequence, it will be difficult to see a particular order, and in fact there is a repetition here. Okay, but there is an order. This sequence is gotten by the addition, a term in this sequence is gotten by the addition of the two preceding terms. You can see that this 2 is gotten by addition of 1 plus 1, you get 2. You add 2 plus 1, you get 3. You add 3 plus 2, you get 5. You add 5 plus 3, you get 8. 8 plus 5, you get 13. 13 plus 8, you get 21, and so on and so forth. It is only the first 2 terms that does not obey that rule. The order from the 3rd term upwards obey that rule. 0 plus 1, you have 1. But these first 2 does not obey the rule. That is what we refer to as what? Fibonacci sequence. It's also a special type of sequence. We also have polynomial sequence. Polynomial. We also have polynomial sequence. A polynomial sequence is a type of sequence whose terms are gotten using a particular quadratic or polynomial function. It's something like when you have a formula. If you have a formula like this, n squared plus 1, for instance, okay, where n is the position of the term, that is in 1, 2, 3, 4. So for the first term, n becomes 1. If you substitute 1 into this, have 1 squared plus 1, so the first term is going to be 2. If you substitute 2 into this, 2 squared is 4 plus 1, you have 5. If you substitute 3 here, 3 squared is 9 plus 1, you have 10. If you substitute 4 here, 4 squared is 16 plus 1, you have 17. If you substitute 5 here, 5 squared is 25 plus 1, you have 26. Okay, this is what you call polynomial sequence. If you are using a formula, this is for n squared plus 1. So if I'm using a formula like say n squared plus n, for instance, in this type of sequence, let's say the first term is 1, substitute 1 here, 1 squared plus 1 is 2, 2 squared plus 2, 2 squared is 4 plus 2 is 6. We substitute 3 here, 3 squared is 9 plus 3 is 12. You substitute 4 here, 4 squared is 16 plus 4 is 20. Substitute 5 here, 5 squared is 25 plus 5 is 30. Substitute 6, 6 squared is 36 plus 6 is 42. So in that order. So this is what you call polynomial sequence. It follows a polynomial function expression such as quadratic and polynomial of a particular order. So of higher orders. So if you look at this now, we can also have what we call triangular sequence, square sequence, cubic sequence, which we generally call it figurative sequence. Figurative sequence. If we have a number such as 1, 2, 4, 7, 11, 16, ... You realize that this type of sequence is a sequence where the number added increases, but increases in a particular order, which is a linear form. If you add 1 to 1, you get 2. Add 2 to 2, you get 4. Add 3 to 4, you get 7. Add 4 to 7, you get 11. Add 5 to 11, you get 16. You see that the number increases using a linear order, which we call linear sequence. The number that we add forms a linear sequence. This is a type of figurative sequence, or a triangular sequence, as the case may be. Under this figurative sequence, we can also have a square sequence, such as the square of natural numbers. If you square 1, you get 1. Square 2, you get 4. Square 3, you get 9. Square 4, you get 16. Square 5, you get 25. You can square of or cube of natural numbers. The cube of 1 is 1. The cube of 2 is 8. The cube of 3 is 27. In that order. It will continue to go in that order. Okay? That is what you refer to as figurative sequence. So having known this type of sequence, there are other types of sequence that we will meet in our mathematical lives, but we are going to limit ourselves to this point, and then we're going to look at questions. What we ought to do is to see how we can identify this sequence, see how we can, when we're solving questions, we'll be able to identify the type of sequence that it is. Okay? We're able to identify the type of sequence that we are solving, so that we will see how we can calculate. So we start from the first one we looked at, which we refer to as arithmetic progression or arithmetic sequence. Okay, arithmetic progression or arithmetic sequence. From our definition, I told us that an arithmetic sequence is gotten by addition of a constant number to a particular number to get the succeeding number. Okay, so if that is the case, let us say the first number in a sequence is called first term. The first number in a sequence is called first term. First term, which at the course of this study, I'm going to use T1 to represent it, which generally is represented as A. First term is generally known to be A in sequence. Okay? If first term is A, we have number of terms, first term in that order of sequence, second followed by the second term, followed by the third term, followed by the fourth term, and so on and so forth, followed by the last term, which is the nth term. Okay, depending on where the term ends, if it is a finite sequence. Okay, if first term is A, And an arithmetic sequence is a sequence that is gotten by addition of a particular number to a number to get the succeeding number. Okay, we are going to, in arithmetic sequence, the particular number that is always added is called the common difference. It's called the common difference. That is a common number that makes a difference between a number and its succeeding number, and it is represented with the letter D. It is commonly represented with the letter D. So if the first term is A, the second term is definitely going to be A plus that common difference, because that's what we add to the term to get the succeeding term. The preceding succeeding number is going to be adding another D to this second term, so that we'll have A plus 2D. The next one is going to be adding another D to this, so that we'll have A plus 3D. This is the first, this is the second, this is the third, and this is the fourth. Then if we continue to go, then we are going to see there's something I want us to notice here. Now you see that the A is constant in all of them, but the D increases in a particular order. Here, the coefficient of D here is 1. The coefficient of D here is 2. The coefficient of D here is 3. Here, there is no D, which you can actually say that the coefficient of D here is 0. So if we compare the increase of the coefficient of D with the number of terms that we have, if in the first term the coefficient is 0, when the term is 2, the coefficient is 1. When this is 3, the coefficient is 2. So it means that the nth term of a sequence is 1 greater than the coefficient of D. So that if this is n, then the coefficient of D we are going to have, if this is A plus, the coefficient of D is going to be 1 less than n, then we have a D. Okay, so that will imply that the general formula for determining a particular term in an arithmetic progression is equal to A plus n minus 1 D. N minus 1 is the coefficient of D. So when this is 4, this is 4 minus 1, that will give us 3. Just like when this is 4, this is 3. When this is 3, this is 2. So when this is 1, this is 1 minus 1, which is 0. 0D is 0, and that's why it is only A that is here. When this is 2, 2 minus 1 here will give us 1, that is 1D, and that's why we have 1 here. When in T3, it will be 3 minus 1, that is 2, that's why we have 2D here. So this is the general formula we are going to be using to determine the nth term of an arithmetic sequence, arithmetic progression, as the case may be. So let us look at a few questions concerning arithmetic progression. Okay, let's look at this simple example just to give us a background of arithmetic progression. They said find the next 2 terms of the sequence. Okay, if you look at this sequence, we need to know the kind of sequence it is. You will see that 7, if you add 3 to 7, it becomes 10. If you add 3 to 10, it will be 13. So the number that is added to a number to get the succeeding number is 3. And because there is a constant number always added to get the succeeding number, that satisfies the definition of arithmetic progression. So we are going to say that this is an arithmetic sequence. So solution. So the first term A, you remember that the formula to get an particular term or an nth term of a sequence, as I have stated, is A plus n minus 1 D. Okay, so these are what we need to get the next 2 terms. Of course, here we have the first term. We have 3 terms. 7 is the first term, T1. T2 is 10, and T3 is 13. So it means that A, which is here, is 7. N is what we need. The next 2 terms we need are 2, T4 and T5. They are the next 2 terms we need in this sequence. So if the first term is 7, And for the fourth term, n is 4. For the fifth term, n is 5, just like we have tn here. What we don't have now is d, which is the common difference. How do we get the common difference? The common difference is that number you are going to add to a particular number to get the other. This is common because it's the same number. So the common difference is usually gotten by subtracting a number from the succeeding number, t2 minus t1, or you can as well say t3 minus t2 in that order. So if that is the case, our common difference is equal to t2 is 10, t1 is 7. So it's going to be 10 minus 7, or you can say it is 13 minus 10, and that's going to give us a constant number 3. So having gotten that, the fourth term, which is t4, is going to be equal to the first term using this formula. The first term is 7 plus fourth term 4 minus 1, and then the common difference is multiplied by d, 3, and that is going to give us 7 plus 4 minus 1 is 3 times 3. Of course, in your board maths, you do multiplication before addition. 3 times 3 is 9, plus 7 is 16. So the fourth term is 16. Then the t5, which is the fifth term, the first term, the same formula, 7 plus n is 5 this time around, minus 1 times 3. Okay, and that will give you 7 plus 5 minus 1 is 4 times 3. And 4 times 3 is 12, plus 7 will give you 19. So the next two terms, are 16 and 19 for this sequence. So we have 7, 10, 13, 16, 19. You see that after 13, if you add another 3, you get 16. Add another 3, you get 19. So this is the formula, like I said, to get an n stem of an arithmetic progression or a linear sequence. This is just one of the type of questions we'll see. Let us look at another question. To find the seventh stem of the sequence, 15, 13, 11, and so on and so forth. Like I said, you need to know if it is the type of sequence it is before you know what to solve. So looking at this, I already know that it is an arithmetic progression or linear sequence. How do you know that? Just first of all, get the common difference. Get the difference and know if it has a common difference. Once it has a common difference, it is an arithmetic progression. So let's check. D is, I said, is t2 minus t1. It can also be said t3 minus t2. Just the next number minus the number preceding it. So it will be that d is equal to, if I say 13 minus 15, this is t2 minus t1. I can also say 11 minus 13, 11 minus 13. Let's see, 13 minus 15 will give us minus 2, right? 11 minus 13 will also give us minus 2. So the common difference is minus 2. It has a common difference. So the number we are going to add to 15 is minus 2 to get 13. The number we are going to add to 13 is also minus 2 to get 11 in that order. Okay, so having seen the common difference, the first term, which is a, is 15. The first term, which is a, is 15, as you can see. Then the question said we should find the seventh term. You see that the previous question we said we should find the next two terms, which even if you don't know have the formula for arithmetic progression, you can actually solve that one. If you know a particular number added, you can just add and get the next, add again and get the next. But in this case, we have only 3 numbers and we're looking for the seventh number. This implies that we don't need the fourth, we don't need the fifth, we don't need the sixth. So if you don't have this formula, the implication is that you will first stretch yourself, or first of all get the fourth, the fifth, and the sixth term before getting to the seventh. What if you are to the 90th term? Is that how you're going to continue to get the next, all the terms up to the 90th term? You see, it is not reasonable at all and it's a waste of time. So that is one of the advantage, or the advantage of this formula for an arithmetic sequence, where we say Tn is a plus n minus 1 times d. Okay, and we've gotten our a, we've gotten our d, then the n is that particular number you're asked to find. You see, we're asked to find the seventh term, which is t7. That's what I use to represent the nth term of a sequence. The seventh term is the T7. So T7 is going to be, first term here is 15 plus the n is 7 minus 1 times the common difference is minus 2. So we are going to have 15 plus 7 minus 1 is 6 times minus 2. And remember, I always tell you that you use BODMAS when you are simplifying expressions in mathematics. Multiplication comes before addition. So 6 times minus 2 will give us, that is 15. 6 times minus 2 is minus 12, minus 12. Therefore, T7, which is the 7th term, is 15 minus 12, and that will give you 3. So you see, the first term is 15, the second term is 13, the third term is 11. If you continue to subtract add this common difference minus 2 to 11 and other numbers that come after it, you realize that the seventh one will be 3. But you have seen how we are able to get the seventh term without getting all the terms before it. We just use this formula and jumped to get a particular term in the sequence. And that is how arithmetic progression or arithmetic sequence works. Okay, we can still look at further examples or to see how this sequence is manipulated. We'll see how this sequence is manipulated in different forms. Okay, the question here says find the 6th and 15th terms of an AP whose first term is 6 and common difference is 7. You see, this sequence, there is no list of numbers. So it is an emerging sequence, a hidden sequence. And that is why you can see that the question clearly stated that it is an AP. Because there is no way for us to determine the type of sequence if the sequence is not there. So in the previous questions we solved, we realized that the list of sequence, the list of numbers that form the sequence is there. And because they are there, we can actually from them discover the type of sequence it is. But here, because we don't have the list of numbers, we cannot actually determine if it is an AP, and that is why it is clearly stated here that this sequence is an AP. Without knowing the sequence, find the 6th and 15th term. But we are given the first term, we are given the parameters needed to get the 6th and the 15th term. So what we will need first of all is to identify our parameter solution. I'm going to split this board into 2 so that I'll be able to solve it differently. So the system I use T6 to represent it. There's something I want us to discover also before we continue. We see that I said that the coefficient of the common difference is 1 less than the nth term. So if this is T6, instead of using that formula a plus n minus 1d, I can just use a plus 5d. A plus 5d, knowing that the coefficient of the common difference is 1 less than this n here. So when this is 6, the coefficient of the common difference will be 5 for an arithmetic progression. So the T6 is a plus 5d. The T15, of course, is now going to be a plus 1 less than 15 is 14, then d. As simple as that. So we can just start this way. No need repeating the formula over and over again. So having known this, then we are told that the first term is 6. That is, A is 6. And the common difference is 7. D is 7. So we can simply get the system by substituting these values. The first term is 6 plus 5. The common difference is 7. So we are going to have 6 plus 5 times 7 is 35. Then the 6th term will now be equal to 6 plus 35 will give us 41. So the 6th term is 41. The same way we can get the 15th term. The first term is 6. The common difference is 7. Okay. So we have 6 plus 14 times 7 is 98, if I am correct. 14 times 7 is 98. Yes, it's 98. Therefore, T15 will be equal to 98 plus 6 is 104. So the 15th term is 104. The 6th term is 41. Without having the sequence, without knowing the list of numbers that form this sequence, just by knowing the first term and common difference, we can determine how the sequence will be, or a particular term of the sequence. You can see different ways this question can be formed for an arithmetic sequence. We'll look at other questions. Why I'm doing this is that you can see it will help you identify different patterns of questions that can come on this particular subtopic of sequence and series. So let's look at this one that says find the number of terms in the arithmetic progression AP. Okay, this type of sequence is finite because we are given the last term, there is no dot 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 that continues. It ended in -141. So it is a finite sequence. It has an end. So the question has already stated it is an AP. But if we are not sure, we can confirm by subtracting the second term, the first term from the second term, the second from the third. If it has a common difference, then it is an AP. So knowing that, how do we get the number of terms? You see, in this one, we have already been given all the terms, but decided to skip some of them. So we do not know how many terms are in between. Assuming we know all those numbers in between, we just count, and that becomes the number of terms that are in the sequence. Okay, but since they decided to remove numbers in between, we don't know whether it is one number that should be here, or 2 or 3 or 4 that will tell us how many number of terms that are in this sequence. So our job now is to get the number of terms. To get the number of terms in a sequence, we use the last term. We use the last term as the Tn. So the Tn is the last term, which I use L to represent. And the formula for the last term, or Tn, which I have stated, is A plus n minus 1d. If we use this formula, we will get n. That's what we're looking for. That is the number of terms. Number of terms is represented with n. Okay? In this previous ones we solved, we were given the number of terms. We were given the term we ought to find. So, but here now we want to get how many terms are contained in this sequence. So, if we say that the last term is -141, that is L is -141, A is the first term, that is 2. Then the common difference is the second term minus first term, that is -9 minus the first term, which is 2, or -20 minus -9. Okay, let's see what this is going to give us. -9 minus 2 is -11. -20 minus is plus. So -20 plus 9 will give us -11. So the common difference of this sequence is -11. So if we now substitute these quantities we have in this formula, we have that the last term, which is the last term given here as -1.141, have -141 is equal to, the first term is given in the sequence as 2 plus n is what we are looking for, the number of terms, -1, then times the common difference is -11. So if we simplify this, this is -141 equals 2. Okay, we can decide to collect like terms. Let 2 cross the sign of equality and it becomes -2 is equal to n minus 1 times -11. Anyhow, you now want to simplify this to get your answer is accepted. The most important thing is that you follow the mathematical rules. -141 minus 2 will give us -143 is equal to n minus 1 times -11. We can divide both sides by 11. Of course, 11 can divide 143 and give you a whole number. How do you know if an 11 can divide a number? If you have 3-digit number and the middle number is the sum of the two numbers flagging it, the first and the third number, That means it's divisible by 11. Okay, so divide both sides of the equation by minus 11. Okay, so minus 11 here will cancel minus 11 here, and minus will cancel minus here. 11 here is going to give us, into 14 we have 1 remainder 3, into 33 we have 3. So that means that's 11 divided 143 will give us 13. So we have 13 is equal to n minus 1. And then we can move this minus 1 to this side to have 13 plus 1 is equal to n. That means that n is equal to 14. Therefore, that implies that the number of terms is equal to 14. Okay, so if we begin to put all the terms here by addition of minus 11 to a term to get a succeeding term, minus 11 here you have minus 31, you add minus 11 again, you have minus 42, and it will continue to increase, and you end up, before you end up getting all the terms up to this minus 141, if you count them, you will get 14 numbers. That is the meaning of the nth term of this sequence. We continue to proceed and solve. We will see different ways questions can come under AP. Well, we cannot exhaust all, so we just solve one more and we end it here for AP. Okay, here we are asked to find the nth term of an AP 11,4 minus 3. Nth term, when you have to find nth term, it means use that of an AP, it means use that arithmetic progression formula to solve in such a way that you get an expression that is in terms of n, so that all the only unknown or the only variable you have there is the n, because that's the only thing that changes. When it is first term, n is 1. When it is second term, n is 2. When it is third term, n is 3. Every other thing is a constant. So we are going to, since it is an AP, are going to use a formula for AP, which is Tn. I always use Tn. Some textbooks or classes we use U substitute n. It does not matter. So Tn is a plus n minus 1 d, as we've known initially. So from here we can get the nth term if we know our first term and common difference. These are the only two things we'll substitute, and then we'll leave n as n. So if you look at this now, the first term is a from here. A is 11, from here. And then the common difference d is the second term minus the first term. 4 minus 11. No need to confirm because we have been told that it is AP. 4 minus 11 will give us minus 7. Yes, that's the common difference, minus 7. So knowing that, that means the nth term, which is Tn, is equal to 11 plus n minus 1 times minus 7. And if we simplify, we have 11, we open bracket, n times minus 7, we have minus 7n. Minus 7 times minus 1, you have plus 7. Then we can collect like terms here. 7 and 11 are like terms. 11 plus 7 will have 18 minus 7n. So the nth term is 18 minus 7n. So this is like a formula. When you have to find nth term, it is a formula that we can use to get the terms of a sequence, having only the n as the variable, which is just going to be replacing the nth term of a particular sequence. So if we have to find the 10th term now, we just substitute n as 10 here and get it, instead of coming all the way here to substitute first term again, substitute common difference again. No, we can now use a simplified form of it. If it is the 6th term, we'll substitute 6 here. If it is 7th term, we'll substitute 7 here, and so on and so forth. This is a simplified form of this formula. That's what we refer to as the nth term of a sequence. Okay, I hope you enjoyed the class. We are going to see next time when we look at geometric sequence or progression, and then other forms of sequence. We'll solve questions. We have already explained the types of sequence. So in our subsequent videos, we are just going to be solving questions from these different types of sequence so that we'll get used to it. See you. Bye.